Okay, I called it angles of elevation and depression. That's kind of the vocab that says it's really trig applications. Trig applications. All right, so I first need to tell you two vocab words, and then we're just going to do three examples, which is just some applications of trig. The two words are this: angle of elevation and angle of depression. The definitions are kind of in the word there. So an angle of elevation is an angle. It's going up, right? Elevate, going up. Here's the technical definition: formed from a horizontal line in the line of sight. It doesn't have to be a person. It could even be like a table, or just, it doesn't have to be anything like a human or anything actual organism. It could just be like a rock or the ground or something, but it has to be a line of sight from that object. In this case, to the top picture. Horizontal line of sight. That's your angle of elevation. Angle of depression. Depression, sad, going down. So it's going to be this angle. The owl's looking down at the squirrel. Horizontal line and a line of sight, meaning what it's looking at, what you're looking at. That'll be the angle of depression. Okay, now what you should notice about these, here's the ground. It's also horizontal. Here's the horizontal line with the owl. Horizontal. So those are parallel. Two horizontal lines are going to be parallel. What type of angles are that one and that one? Alternate interior. This is, I'm just going to put AE if that's all right. Oh, that looks like alternate exterior. I'm going for angle of elevation. That's the angle of elevation. That's the angle of depression. Because the lines are parallel and they're alternate interior, they're going to be curved. So the angle of elevation from the figure that's on the bottom, I guess, looking up, is the same as the angle of elevation of depression from the object up looking down. So one picture and angle of elevation and depression are always congruent. So I say that here, the angle of elevation and depression are always congruent because the two angles are alternate interior. Alternate interior angles. Let's see. So before we just do some examples, here I wanted to show you two other pictures where they clearly say, all right, here's the angle of elevation and depression. So guys, angle of elevation, usually no problem with that one. Angle of depression, here's what a lot of people want to put. They want to put it in this triangle. It's that one. The one with the lifeguard right here, right? Okay, but that would be a vertical line in the lifeguard's line of sight. Okay, so that is not the angle of depression. It's this one. Look at that. It's this one right here formed by a horizontal line in the line of sight. Okay, so let's do a couple application questions. Any thoughts on those vocab words? So you just got to know those, and then we can do the application questions. So, all right, let's go to this one. So sometimes they'll give you a picture, sometimes they won't. Here's one where they do provide us a picture. A signal tower is 120 meters tall. It's labeled in the diagram. The angle of depression from the top of the tower to the ship is 25 degrees. How many meters from the foot of the tower, the base of the tower, is the ship? All right, I'll call that X. So here's what I want you to do. Label those two. Because most of what this section is having a good picture labeled correctly and then setting up a trig equation. So I want you to label the X, what we're trying to find, and I want you to label 25. Take 30 seconds, label those two. Okay. Well, a lot of us got X, right, as I'm walking around. That would be this, right? From the bottom of the tower over to the ship. That's what we're trying to find. A lot of you put the 25 here, though. That's just an angle in the triangle, but it's not the angle of depression. Okay, so the angle of depression is actually that one. Now you don't actually have to, let me say this. I actually hardly ever even draw in an angle of depression because I know it's equivalent to the angle of elevation. So really, I don't usually even draw on that 25. You have to draw on an extra line. It's not even part of the triangle. So whenever I hear angle of depression, I really just think angle of elevation from the opposite figure. So from the ship up to the top of the tower, there's the angle of elevation. You can put the other 25 in there if you want, but really just need the one at the bottom. All right, so then now it's a trig problem. It's a right. There is a right angle there. It might be hard to see. Assuming it's perpendicular to the ground. And what, this is 120, and this is x, and 25 degrees. You do not have to redraw the triangle. I'm just showing you how it looks if it was just back to a normal trig problem. Okay. So now it's trig. I label my, start with my acute angle. I label the sides. This would be the hypotenuse. Opposite 25 is the OPP. And the ADJ is the third side. I don't even have the hypotenuse. I have the opposite and adjacent though. And so that's tangent. Tangent of my acute angle, 25, is equal to opposite 120 over adjacent x. So if you can see, I mean, it's really this section is just one extra step, like have a picture and label it correctly. Other than that, it's just the same as before. Set up a trig equation and solve. This one variable down low, so we'll switch her up. X is 120 over tangent 25. We put it in our calculator and we'll get what we're looking for. So thank you. And none of these, I didn't have any of these say really what to round to. You said 257 something? Yeah. So let's 0.3, right? Okay. So let's just round to the nearest whole number on this one. About 257 meters. Okay, that's our first one. I want to do two more today. Any thoughts on those? On that one? Now, the next one is no picture, so I'm going to draw a picture. It's all about carefully drawing it and then labeling it, and then it's the trig problem. So, by the way, there's change the name here. They're both supposed to be Natalie. So Natalie's looking up at the top of the Statue of Liberty. I don't know why, I just different name there. Natalie's looking up at the top of the Statue of Liberty. So here's her down here, and Natalie. Looking up at the top of the Statue of Liberty at an angle of elevation of 61 degrees. I am not an artist, so please bear with me on this. Here's the Statue of Liberty. Right, that's supposed to be the torch. It looks more like a popsicle, but that is the torch. I'm gonna put SL here just so you know that's the Statue of Liberty, just to clarify.
Just in case.
It kind of looks like Natalie, actually. It's the same. That's an N too. All right. Now notice here, so she is from her eye level. That's where she's looking up. So do not draw the triangle here. Don't draw from her feet up to there. You get close to the height if you did it this way, but you actually be a little bit off. Right? So you get somewhere close, but it would definitely be off. But the angle of elevation is directly from where she's looking here up to the top. So really what we formed so far is actually a trapezoid, like that. So the trapezoid on its side. To form the triangle then, I've drawn the horizontal line, right? This is the line of sight in red, and then here's the horizontal line, right there. So really my triangle is starting at her eye level. I'm just drawing it separately again, you don't have to. The angle of elevation is 61 degrees. That's there. Let's label what else we know. We know that she is 5.5 feet tall, so that's her height. She's standing 166 feet from the bottom, the base of the statue. So Natalie to the statue is 166. Yeah, it's down there, but that's going to be the same length from her eye level over. So we can also put the 166 here. Finally, find the height. So this is going to be our x. Find the height. Now, when we do this, my x is just going to be from the top to somewhere here. It's not going to be all the way. Right, my triangle doesn't go all the way down. So what I'm going to have to do is I'll do a trig equation, and I'll get all of this here to here. Then this length is 5.5. So after I'm done, I'm going to add 5.5. So separately, let me redraw the triangle. 61 degrees here, x here, and 166. That's the setup. After I do the triangle and get x, then I'll add 5.5. So now it's back to trig. So there's my acute angle. I'm not going to label the hypotenuse. We don't have it. Here's opposite and adjacent. It is, again, tangent. Let me say this. A lot of these application ones are tangent. That's why it's my favorite, yes. That's good you remembered that, yeah. Not always. I don't like every time put tangent. It's not. But more often than not, it is. Tangent of my acute angle 61 equals opposite x over adjacent 166. Variable up high, so we'll multiply. So I'm going to clear the denominator by multiplying by 166. Okay, just to save a little time here, when you put that in your calculator, you get about 299.5 feet. 299.5. So that was x, and now we just need to add in 5.5 to get all the way to the ground. That'll be about 305 feet. Yes, that actually is the height of the Statue of Liberty. Okay, so that one is, you can see some of these are just very similar to set up, but this one we had to add 5.5 to. They're all going to be a right triangle somehow in trig. Somehow we'll have to solve for x slightly different every time. Anything I can answer on that one? Okay, let's go to the last one here. Sailboat question with Olivia. I was so happy yesterday, guys. I was looking up some good problems, some state test-like questions. And no joke, I found a lot. I found some good ones. I have loved this type of problem. There's different ways they can ask it. But guess what? I was looking at these questions. I found one, state test question. It was sailboats, and it was the exact same question, just different numbers.
Crazy.
I know. I was so happy. I was so happy. Here's what they're asking. I'll tell you. Find the distance between these two sailboats. So they're asking for the length of AB. What's going on is Olivia is up in the lighthouse at point C. She's looking down at these two angles of depression, 33 degrees and 57. And that's it. Find the distance between the two sailboats. Now, the one other thing from the diagram is it does tell us that this is 85, the height of the lighthouse, and the cliff is 110 feet. So we can conclude that this whole length here is 195 in reality. Okay, so let's look at it. AB is not even a right triangle, so we cannot do trig on that directly. We'll have to indirectly find it. Yes? Sure. We'll have to indirectly find it. Okay. So we got to look at the triangles we do have. The first one is this small one. Right, the small triangle there. Let me redraw it just so you can see. So I know that the height is 195. I can find DA. I'm going to call that X. I can find DA. And then I'm just going to fill in this angle of elevation. Now, which one is it? Is it the 33 or the 57 that goes here? 57. Why do you say that? It's hard to, like, if you match it up with this transversal, it's that 57. That is the alternate interior one. I thought you were going to say this. The other thing that I tell students on this is, if you're in this sailboat, wouldn't you have to look up at a higher angle to look up at the top? Like, you're closer, so you have to look, if you're close to something, you got to look up a lot more. It's got to be a sharper angle. It's got to be a bigger angle. When you're far away from something, you don't have to look up as much. You don't have to look up. She was trying it out. Yeah. You don't have to look up as much here. So this is the 33-degree one. They actually don't have to tell you which angle. They don't have to even give you this here. They could just tell you over here, and you have to conclude that the closer one is the bigger angle. So let's finish off the red triangle. I can solve for x. Yes, it is tangent. So this was 57. Opposite here and adjacent here. It's not always tangent, but it happens to be. So tangent of my angle, 57, equals opposite, that's 195, over adjacent x. I'll do the old switcheroo. It's all the old switcheroo. So the variable down low, switcheroo. So x is going to be 195 over tangent 57. I got that?
126.6.
Give it 126.6. Okay, so that is D to A. That's good. Now, again, AB is not a right triangle. But what I'm going to do is just redo what I just did for the big triangle. All right, so that big triangle now, the angle's 33, the height is still 195, and I'm going to call this from D to B. Hey, you call it X if you want. I'm going to call it Y, so it's a different variable. And all I'm going to do once I get this, I'll have this distance, and I'll have the whole thing, and I'll just subtract. And that'll give me an AB. So let me do the purple triangle. It's the same problem, it's just 33 is the only difference. So it's still tangent of our angle. Opposite over adjacent, 195 over y. Still do the switch here, so it's 195 over tangent 33. And let's write it down. It's about 300. Yeah, 300.3, 300.27. That's what I wrote down. Yeah. Basically, we got the whole distance, and we got dA. So the sailboat distance is when I just subtract these. So I can take the 300.27 and subtract off the 126.
On the test, would we not like round yet?
Yeah, you know what? Watch what I'm doing. I don't round until the end. So now at the end, it's about 174. Yeah, don't round it to 300 and 126 early. You'd be fine here on this one.
But didn't you already round them? Like,
Which one?
both those.
I mean, slightly. They keep going.
But you can round that.
The final one, I'm just gonna. It says to the nearest foot. But yeah, don't round the other ones early. I mean, you can. Technically, you should leave it in your calculator as that whole decimal. If you're not sure, 3 decimal places will usually be fine. Yeah, so at least 3. Okay, good job. Yeah, we gotta wrap it up there.
Huh?